Look down at your feet. You have two shadows. They fall in slightly different directions, and through the long afternoon, they drift apart, then slide back together. Because the light pouring over this world does not come from one sun. It comes from two. By evening, you will watch both of them sink toward the horizon, one trailing the other down into the dust. A double sunset, the most famous skyline in all of science fiction. Except this is not science fiction. Worlds with two suns are real. We have found them, cataloged them, learned their names. The only question left is what it would actually be like to stand on one and look up. For decades, the twin suns of Tatooine were a symbol of pure fantasy, a painted horizon in a galaxy far, far away. Then in 2011, NASA's Kepler Space Telescope found the real thing, a planet called Kepler 16b, circling not one star, but two, locked in a tight orbit around each other. The scientists who discovered it did not even try to resist. They nicknamed it Tatooine. And here is the fact that quietly rearranges everything you assume about the night sky. Our single solitary sun may be the exception, not the rule. Roughly half of all stars like the sun are not alone. They are born in pairs, sometimes in threes and fours, bound together from birth and wheeling forever around a shared center of gravity. So the real mystery is not why two sun worlds exist. It is how any planet manages to survive them. There are two very different ways to live beneath a pair of stars. In the first, the two suns huddle close together, and your planet circles the whole pair from far outside, like a single moth orbiting two candles held side by side. Astronomers call this a circumbinary orbit. From the ground, your two suns stay near each other in the sky, rising together and setting together, never drifting far apart. This is the true Tatooine arrangement, and the one Kepler 16b follows. In the second, the two stars are flung far apart, and your planet hugs just one of them. The other sun burns as a distant, brilliant companion, too far away to warm your skin, yet bright enough to outshine every star in your night and to cast its own faint, lonely shadow across the ground. Our nearest neighbors, the stars of Alpha Centauri, are a system like this. Two sun-like stars, circling at a wary distance. Two architectures. Two utterly different skies. But both must answer to the same merciless law, the law of stability. Two stars do not make a calm place to live. A single sun holds its planets in smooth, patient ellipses, the same path traced faithfully for billions of years. But two stars swinging around one another pull on a planet from a direction that is always changing. Drift too close to that whirling pair, and the competing tugs add up, orbit after orbit, year after year, until the planet's path begins to wobble, then to lurch, and finally the world is either hurled out into the cold of interstellar space or dragged in and swallowed by one of its own suns. In 1999, the astronomers Matthew Holman and Paul Wiegert worked out exactly where that danger ends. Around every binary lies a forbidden zone, an inner region where no stable orbit can possibly survive. To endure, a circumbinary planet has to keep its distance, orbiting beyond a critical line at very roughly 2 to 4 times the gap between its two stars. And here is what makes the data so striking. Almost every circumbinary planet Kepler has found sits just beyond that line of no return, pressed as close to its suns as gravity will permit, and not one step nearer. These worlds live their whole lives on the very edge of the abyss, balanced on the rim of the forbidden zone. Now stand on such a world and lift your eyes to the sky. Your two suns need not be twins. One might be a warm, yellow-white star, much like our own. The other, smaller and cooler, might glow a deep amber, almost orange. Together their light mixes into a strange doubled daylight and lays those two soft shadows at your feet, each one faintly tinted by the color of the sun that is not casting it. Sunrise is no longer a single event. The two suns can climb above the horizon minutes or hours on apart and set just as far out of step so that one day might hold two separate dawns and two separate dusks in a pattern that never repeats exactly the same way twice. On some afternoons, the suns drift wide apart across the sky. On others, they slowly converge, until one slides in front of the other in a deep, lingering eclipse, and the whole world dims as though a vast cloud had drawn across the heavens. There would be days drenched in double brightness, and days when one sun veils the other, and the light falls strangely flat. Across an entire lifetime beneath that sky, no 2 days would ever be quite alike. For life, one question rises above all others: liquid water. A world cannot be so hot that its oceans boil away, nor so cold that they freeze solid. Astronomers call that narrow, comfortable band around a star the habitable zone. Around a single star, the habitable zone is a simple, steady ring. Around two stars, it becomes something far stranger, something that moves. Because the suns are forever orbiting each other, the total light spilling onto your planet swells and fades as they go. When both suns swing to the same side of their dance, their warmth piles together. When they sit on opposite sides, the flood of light evens out and softens. The habitable zone itself pulses gently in and out, like something breathing. A planet there does not simply bask in steady sunshine. It rides a slow, surging tide of starlight, laid over the top of its own ordinary seasons. And astonishingly, we have already found worlds resting inside that breathing zone. Kepler 47c, one of several planets circling its pair of suns, and the giant Kepler 453b both orbit at distances where, in principle, liquid water could endure on a suitable world. So picture lifting our own Earth out of its quiet, familiar orbit and setting it down around two suns instead. The first thing to change would be distance. To stay safely beyond the forbidden zone, Earth would have to swing wide around the pair, far enough out that a single year might stretch to many hundreds of days, perhaps far longer still. And to keep our oceans from freezing at that range, the two suns together would have to blaze at least as brightly as the single sun we left behind. Then the calendar would turn baroque. Our familiar seasons, born from the simple tilt of the planet, would still be there. But now they would be overlaid with the slow surge and ebb of two suns brightening and dimming as they circle each other. Eclipse seasons would arrive and pass. The length of a day and the warmth it carried would wander from one date to the next, never settling into the steady rhythm we take for granted. Life, almost certainly, could still find a way, but it would evolve under a sky that keeps time very differently, beneath two suns and the two long shadows they forever cast. And none of this is guesswork any longer. One by one, we have begun to find these worlds for real. There is Kepler 16b, the very first, a cold Saturn-like giant, the original Tatooine. There are Kepler 34b and Kepler 35b, a matched pair of gas giants discovered soon after, each circling its own twin stars. There is the Kepler 47 system, where several planets orbit a single pair of suns at once, proof that two stars can cradle not just one world, but an entire family of them. And there is Kepler 1647b, the largest circumbinary planet found so far, a Jupiter-sized world on a vast years-long orbit. Then there is TOI 1338b, a two-sun world announced in 2020, not by a veteran astronomer, but by a 17-year-old intern, only days into his summer at NASA, patiently scrolling through the flicker of distant starlight. Almost all the two-sun worlds we have found so far are giants, the easiest kind to see across such enormous distances. The small, rocky ones, the true second Earths circling two suns, are still hidden just below the threshold of what our instruments can detect. But if half the stars in the sky truly come in pairs, then somewhere out there in the dark, those worlds are almost certainly waiting to be found. We grew up beneath a single sun and quietly assumed the rest of the universe must be the same. It isn't. Out there right now, tonight, there are worlds where two suns climb the morning sky together, where every afternoon lays down a pair of shadows, where the strangest, most cinematic sunset we ever dreamed up is simply the way the day ends. Tatooine was never the fantasy. The fantasy was ever believing that we were the normal ones. Somewhere, that double sunset is real, and the cosmos has been staging it patiently in silence, long before we first looked up and dared to imagine it.